This is the Arduino ball and beam project. It's a ball balancing device, and it's through the School of Engineering at Western Illinois University, and it's for Engineering 373. I'm Rebecca Bishop.
I'm Matthew Bingham.
And I'm Colin Roberts.
So our project is for, as we said, Engineering 373. It's our linear control systems class. And the goal is to learn how to properly implement feedback in a system to eliminate unwanted noise. Our system is actually going to use a PID controller, which we will learn about later in the semester, but so we've had to do a lot of this research on our own.
Okay, so an overview of our project, just to give you an idea, is we will have a beam where you balance a ball on top of the beam, and the ball will be balanced in the center of the beam, and it'll do this with using a servo motor that uses feedback from distance feedback from an IR sensor, using the speed and position to move the ball, or to move the beam, to move the ball back to the center of the beam. And to process all the data, we went with Arduino microcontroller that we will discuss later in the presentation.
The PID controller is a proportional integral derivative controller, and it controls the feedback of the system based on the speed and position. And so it interacts with the sensor and the servo, and the constants of the PID equation are Kp, Ki, and Kv, and they control the actions of the system.
The microcontroller we chose is the Arduino Uno R3. We chose this one because it's very easy to use. There's lots of documentation online. The coding is simple. It has more than enough performance for our needs for this particular project. As you can see, it's got the 14 I/O pins. It's got a range of 0 to 5 volts for operating voltages. It's got more than enough memory for what we need, and the 16 megahertz clock cycle is just fast enough. One of the reasons we chose this also is because all of us had this particular Arduino already on hand from past projects.
For distance measurement for the ball, what we have currently mounted isn't going to be quite sufficient for what we need. It doesn't have enough, doesn't have a good effective range, and so we're still waiting on this component for our project. We have the other IR sensor mounted, but the one we are going to be using is the Sharp IR distance detector. Has an effective range between 10 and 80 centimeters, so it'll be plenty for the length of our beam. This will detect the ball rolling on the beam and send the distance measurements back to the Arduino for processing.
The servo motor that we're using is a high-tech HS645MG. It exceeds the power requirements that we actually need for this. It's connected to the beam via a rod, and it will move the beam up and down to adjust where the ball is on the beam. And we did have to add to the rotor part that actually rotates. We extended the length out so that we had more distance that the beam could travel up and down.
So far in our project, we received all of our components except for the IR sensor that we had mentioned. We have made all of the mechanical portions of it. So the platform, the beam, we've made them all out of aluminum extrusions, which is primarily aluminum. But most of the components are mounted. They aren't necessarily permanent because, again, we'll have to swap out the IR sensor, and we're kind of fine-tuning locations of individual components. And the programming is partially completed. We're most of the way there. We just got to kind of tweak it based on where we're going to actually have our final position of our components.
Okay, so this is our current physical system at the moment. Like Matt talked about, everything here, or mostly everything here, is made from aluminum extrusions. Um, the top beam is where the ball will be balanced on. As you see, the ball will always be balanced on the center and will change with external forces put on it, and will always go back to the center based on where you put the ball. On the top right of that beam, there's our little IR sensor, which we will be changing when we receive our other IR sensor. The second beam below the main top beam is where we mounted our servo. With that, the purple piece is the extrusion that Matt talked about, with the rod connecting to the top beam. And then also on that beam we have our mount for our Arduino microprocessor, which is connected to the servo and also the IR sensor through the aluminum extrusions.
And for our future objectives, we need to do the final circuit layout and diagram, finish our final design, tune our PID controller for stable system, and that's adjusting it for sensitivity and so that it's not just winging the ball across the room when we start it up and stuff like that. Final design review for our presentation for our class, and our final deliverables for Engineering 373, which is due next week on the 5th.
All right, thank you for watching our presentation. If you have any questions or comments regarding any of the information you heard today, go ahead and let us know in the comment section.